Good afternoon, colleagues, and welcome to this plenary session where we're going to be looking at UK, European and international challenges of delivering CCS from geographically dispersed industries. My name is Julia Race. I'm a reader in pipeline and subsea engineering at the University of Strathclyde, and I'm pleased to be able to present this interesting panel with a series of very inspiring speakers. What we're going to do is each speaker is going to speak for 10 minutes, and then after that we'll have our plenary discussion. So if whilst the speaker is speaking, if there are any questions that you come to your mind, if you could just hold them till we get to the end, and then we'll get the whole panel up and you can then ask your questions. For those who are online, if you could ask your questions in the question and answer spot, then I can pick those up and put them to the panel as well. So without further ado, let me introduce our first speaker, Aaron Gota from Baringa. Aaron currently works on industrial decarbonisation and hard to decarbonise sectors at the consultancy Baringa. He was previously at the UK Climate Change Committee for 6 years, where he led work on industrial decarbonisation, and he provided influential advice on to the government on setting of the UK's net zero target and 6th carbon budget. Aaron has also previously worked at the UK Parliament for 5 years and at the British Geological Survey. So, Aaron.
Thanks very much, Julia, and hi everyone, and thanks very much for the introduction. I just want to say it's really great to be back. I was an early career researcher and I recognise several, but not all faces here. I think the first one of these conferences I came to was in 2009, which not forever ago, but it feels like a wee while now. So anyway, really great to be back, and yeah, I really love coming to these conferences. So as Julia mentioned, I recently moved to the consultancy Baringa. We have a focus on energy and climate change topics, and was previously at the Climate Change Committee. And I guess over the past, let's say 3 or 4 years, this has been a topic that has really been sort of floating in my mind, and that I've been thinking a bit about from time to time. And that was mainly in the context of the setting of or advising on the UK's net zero targets and carbon budgets, because when we started to think about net zero, it became clear that you kind of need to reduce all emissions or most of them and offset a few, and so you have to start thinking about the hard stuff. And I think that dispersed industries and applying CCS to those is in that bucket. So hopefully the pointer works. So what I want to talk about is I think the hard stuff, the hard to decarbonize stuff, particularly those sites that are really in need of CCS. So those that don't have good alternative decarbonisation options, those that are located far from I'm going to call them the pipeline clusters. Perhaps this is sort of track 1 and the reserve cluster. Are those that are more likely to be considering shipping, road, rail, and I haven't got too much more on this, but also CCU. And these sites are also often characterised by the fact that their location is often influenced by, for other competing reasons. They might use resources that are in the centre of the country. The cement sector wants its limestone from quarries that are near the Peak District. And so some of the sectors, the key sectors that I want to talk about today are energy from waste, the non-metallic minerals, so that's the cement sector, but also lime, ceramics, glass, fossil fuel processing and refining, also some difficult to abate emissions there. There's some edge cases that I'm not going to talk about too much about. Some of the smaller chemicals, waste biomass producers, like the paper sector, they produce some biomass, and sometimes those sites do sit a bit more dispersed. And there's a potentially you might that waste paper is always going to be produced at that site. Do you move the paper to a cluster and then apply BECCS, or do you use it there and transport the CO2? Still, there are competing measures. Perhaps that's a more controversial topic. We're in South Wales. We're near to the site that's perhaps the one at question there, and also too much to power. And so why is this important now? Well, I was already sort of briefly mentioned net zero carbon budgets. They mean that, yep, we need to decarbonize pretty much everything. Looking back at the pathways that I worked on when I was at the CCC, we had the cement sector decarbonising by 2040. That's part of the overall set of measures across the economy that are required, and some things just need to be done sooner if we're going to hit our targets and get the right level of cumulative emissions to meet the UK's overall ambitions, overall international commitments. And why else are these sites important? Well, some of these sites are really quite complicated, and there's going to be quite long lead times to decarbonise them. And so we need to start thinking about some of those now. And in some cases, there might be a few sites that actually that isn't where they end up, and they may even be thinking about moving. And if that is the case for some sites, then they need to be thinking about just transitions for those areas, for the people that work there. And that will be very important for the overall transition, to bring people along. If there isn't a just transition, then we may not keep public on side for mitigation as a whole. So I'm conscious that I'm taking a little while. I don't have too many slides, fortunately. So where are those dispersed sites in the UK? So I had and my team at Baringa, we had some fun playing around with the data that's out there on point sources, and looked at sites under 50,000 tonnes or 0.05 megatons. This is 2020 data, a funny year really when you're looking at emissions data that during COVID. There's around 20 million tonnes that sits within these sites. So this excludes, so you'll see there's some sort of blue circles there. I've excluded everything that's within the sort of track 1 and reserve clusters, or the pipeline clusters. The biggest sites on there's blue, the cement sites, they're all around a megaton. There's the refinery down Solent. I don't know why Pembroke refinery, which should be on the southwest of Wales, is not in the data for that year, but that would also be up there. The largest number of sites, the energy from waste plants, you can see those pink dots dotted all over the place. So the challenges, that broadly and really quickly, they fall into, well, firstly, there's the cost and economics. Well, that sort of boils down to two things, really. One is, well, the need for some stronger policy support. I sort of see myself looking in the direction of government officials. But then secondly, even if there was that policy support, and suppose it was put together in a way that kind of gave a level playing field to all sites, then there's a potential issue here about the competitiveness of dispersed sites. Are they going to be able to produce their products for the same cost as those sites sitting in a coastal pipeline cluster? That is a challenge for these sites. There are several types of infrastructure constraints, including energy constraints for these sites, the same as for some of the pipeline clusters. And there's also several local environmental and planning permission challenges. And I'll run through them in 3 groups in a touch more detail. And you can really split the dispersed sites in the UK into 3 main bundles. First, I will call the kind of slightly easier to decarbonise dispersed sites. These are the ones that are near the major ports, and there's already quite a lot of work on some of these. So, of course, Swick we've heard about this morning, the South Wales cluster, the Solent cluster at south of the UK, is sort of emerging. Very recently, some of you may have heard of kind of small cluster at the top of the Severn River around Avonmouth. And there's several, I've put a few other anchors to represent ports, mainly in the south, I guess, where they're further from the pipeline clusters. And I guess the challenges for some of these are the additional cost of shipping. For some of the largest ones, these won't be quite as much, something like £20 per tonne. For small ports, which perhaps aren't able to host the largest ships, then perhaps a bit higher cost. Then the second type is mainly just the Peak District cluster. Now, perhaps you could put a London cluster in here, but I think there is actually quite a cluster of high emitting sites, a couple of large cement sites in the Peak District, which there is some discussion among industry that a pipeline might be suitable for these, or at least most economically efficient. Rail, which would probably be the next option, pretty expensive. But there's perhaps a challenge here, maybe we might talk about later on, which is, will it be possible to get planning permission for a pipe running through the Peak District to say to the High-Net cluster? And road really, for this size of cluster, this level of emissions really isn't an option. I think I tried to work out earlier on, it's probably 100 trucks a day, which I don't think is feasible in terms of noise and traffic, which is an issue that for some of the other dispersed sites, where they are only single sites, perhaps the local community are not as familiar with traffic noise, may be a bigger issue. But for these sites, and so my third group, I'd say that for these sites, there'll really be a whole mixture of potential options: pipeline, shipping, railroad. There's some great analysis out there produced for government a few years ago that suggests, yeah, there really will be a mixture of optimal solutions to these, but they're not as far worked up. Perhaps they will all end up in one bucket in the end. I mean, for many of them, they clearly won't be shipping, because you can see, and I've removed the other sites I've talked about. These sites sort of almost, I started to see, sort of almost sit on a sort of spine of the UK. So final challenge, sort of already alluded to, is around policy. When I was previously at the CCC, we had a recommendation around the need to build plans and work with industry in these areas. And that's because of sort of the aforementioned potential concern about a just transition in the future if some of these sites actually can't decarbonise. Now, I think in terms of progress, there's actually quite a few small pieces going on at the moment that I noticed. I mean, there's clearly cluster plans in some of those port sites. The Transition Plan Task Force requires listed companies to produce plans. That's, I presume, going to help for some of these sites. There's some technical working groups between government and industry going on. The local industrial decarbonisation plans that are set to be, funding is set to open in the summer. I'm not sure if there's really been any discussions around planning on those difficult pipelines, but I'd be interested to hear from anyone that knows. And then finally, the business models. I mean, I think the main summary here is that we heard earlier on from Luke, lots of great progress on the clusters, but in terms of dispersed sites, the current CO2 transport and storage business model is designed to support pipelines, and moving on to, and has not yet progressed to the stage of supporting non-pipeline transport. That's clearly going to be an important part, and working out which way to do this. It seems more likely that the government might go down the line of doing this through the transport and storage business model, but perhaps it's still an open question as to whether or not the sort of support might go through other business models. But interested to hear more from government really on that one. Now, I'm really conscious that I've taken a little bit over my time, so thank you very much, and I should pass on.
Thank you, Aaron. Our next speaker is Toby Lockwood. Toby is Director of the Technology and Markets for Carbon Capture Europe for the Clean Air Task Force. In this role, he leads analytical work to highlight how carbon capture can help Europe meet its climate goals. Prior to working here, Toby worked on carbon capture for 9 years with IEA Clean Coal Centre and has also experience in pollution control development for the lime industry. He writes regularly on CCS and other energy sector issues for industry publications. So please, Toby, the floor is yours.
Which mic do I use? Sorry, this one. Hi, thanks. Yeah, great to be here. Thanks a lot for the invitation. You're coming to these for a while as well, and always a great crowd. So I'm going to hopefully talk a bit about CATF's work in Europe on CCS, and hopefully touch as much as possible on the theme of this this conference. So just to introduce the organisation for, just going to keep an eye on the time actually. What are we at currently? Yeah, we're a climate NGO, originally from the US in 1996, but in the last few years expanded internationally, particularly to Europe. It's about 160 people, and we're working to create a grandiose mission of creating a zero carbon energy system. But I think our sort of main USP is that we're focusing on a lot of technologies which other NGOs disregard, like CCS, nuclear, and geothermal, lots of other things. So I work on CCS in the EU and more recently in the UK as well. So I'm going to give a little state of play, maybe to take the scope a bit beyond the UK for a moment. So we have a project tracking map on our website, which you can check out. It's got over 70 proposed projects in the EU at the moment. What I want to highlight is that, go on one slide, very few of these have a kind of route to progressing and making a final investment decision. I've highlighted some of the ones which have a stronger case at the moment. They're really in the few countries which have national policies to support CCS deployment. They're really around the North Sea. So there's kind of similar to the UK contract for different style models, either proposed or in place in the Netherlands, Denmark, and in Sweden for BECCS. And there's obviously a kind of grant funding package going on in Norway. So most projects are still facing an economic shortfall, funding gap between the to progress and what the business case they can currently make from the carbon price. So in the context of this conference, I just want to point out that, and there's also funding for 8 projects from the EU's Innovation Fund for large-scale projects. So yeah, in the context of this conference, I wanted to point out that many of these projects rely on shipping. Obviously, we know about Northern Lights and the 2 projects which are linking with that by ship. Most of the other Innovation Fund projects, which are in pink here, are also based on shipping to Northern Lights or somewhere in Norwegian North Sea or the Dutch North Sea. A couple of those are not coastal, so the one in Poland and the 2 in France are not really coastal, so they're also looking at connecting to the port. So yeah, in France you have a cement plant and a lime plant. One of them is using a pipeline to connect to the port. The other one is considering a train. And the Polish one's also considering rail. We can move along. Oh, sorry. Yeah, so this is some of our work in the EU generally. I think our priorities can be summed up as encouraging coordinated build-up of sort of volume optimized infrastructure and policy support which goes beyond demonstration. We've highlighted the gap, or certainly the gap that existed last year in storage availability in the EU and in Europe. The funding gap, basically the gap between the carbon price and what these projects need to develop. And on the theme of this conference, we've campaigned for the inclusion of non-pipeline transport modalities in a piece of EU regulation called the 10E, and we did get CO2 storage included in that regulation, which is very important, but now we're trying to get the non-pipeline transport included in sister regulation called 10T, so that would cover rail, and it basically allows easier permitting and funding to go towards rail and shipping of CO2. Published this report on the European strategy for CCS, and then co-chaired a European Commission working group on what they called a CCS vision, basically developing it was a stakeholder group developing a CCS strategy for the EU. And in response to that, fortunately, the Commission have announced they will be producing a communication on a CCS strategy, which is due this year. So that's a positive result. And even more positively, in the last couple of weeks, I'm sure many of you saw this, in the same week as the positive UK announcement, we saw the Net Zero Industry Act proposed by the Commission, which is sort of their response to the Inflation Reduction Act we heard about in the US. And a lot of it is about ensuring production of clean energy technology stays in Europe, but there is also a huge part on developing CO2 storage. So there's a 50 million ton target for storage capacity that's in the EU, doesn't include Norway and or the UK, of course. And there's also, interestingly, an obligation on member states to kind of share their plans and what storage capacity they will need, but also on oil and gas companies to contribute towards this capacity in proportion to their production. So it's kind of a come take back obligation light, I might call it. So on the transport side, it's interesting that it doesn't really mention this in the regulation, but apparently to count the storage capacity, you need to have access to CO2 either via pipeline or shipping terminal. So the real question is, are we going to have enough captured CO2 to fill these stores when support is so lacking on the member state side in many member states? And where will these transport networks come from? So on the transport network side, how do I click this? Another interesting tool in the EU is these projects of common interest and projects of mutual interest, in which there was an explosion of applicants for the CO2 network candidates late last year. So this is our graphical depiction, still very based around the North Sea. So these are like transport and storage networks with CO2 that are proposed, and if they're successful, they can get easier permitting and some funding, but they're not a great deal, to be honest. But great to see the extension of these projects to the Mediterranean, to Eastern Europe, and there's a lot of big pipelines in this. Actually, there's a few big pipelines. There's a network proposed for the whole of Germany, and also two massive pipelines to Norway, 700 kilometers of pipelines. These are about 20 to 40 megatons in capacity, in annual capacity. So something that EU is really looking at and we're trying to help with at the moment is getting a consistent regulatory framework, because at the moment there's no real alignment on what kind of regulations will govern these pipeline networks or these non-pipeline networks, and what kind of technical standards they'll need to adhere to, because obviously this is going to have to be a cross-border network. Some kind of key non-pipeline corridors maybe are people looking at, there's a project which is looking at taking CO2 by barge along the Rhine from the heavy industry clusters in North Rhine-Westphalia to Rotterdam, and of course a lot of shipping also around all these pink clusters. There's around 20 import and export CO2 terminals kind of covered in this within this. So to turn back to some of our work, just keeping on time. This is an interesting tool some of you might have seen that we put out last month, which attempts to map the cost of CCS, capture, transport and storage across Europe. Looks at facilities over 100,000 tons. There's a few scenarios you can play around with. There's like a high and low value cost estimate. There's a key thing is whether it takes into account currently planned storage sites. So you're about to see if you go to the website, but there's the kind of what they call the short-term estimate here is just considering storage sites that are in the North Sea, and also includes some slightly less advanced ones like the one in Ravenna in Italy, and there's one in Greece. So just considering those, obviously you have quite high costs to get to them, but then we consider the possibility of developing storage anywhere where geology and regulations allow. So I'm going to show like the heat map that generates. So if you only have the planned storage sites, you get these areas of low cost around the North Sea, around southwest France, where there's a nascent project, Italy, Greece, and if you consider all sites which have suitable geology, of course, there's suitable geology in lots of places. Although worth noting, there is suitable geology in Poland, but it's not included in this because it's currently illegal to store CO2 in Poland. That could change, and Germany. And then you can also toggle on new pipelines possible. So the base case, it just considers pipeline reuse, river transport, the rail network, which is maybe an optimistic assumption because you might not be able to use all the rail network, and shipping. And the pipeline reuse is based on the carbon limits restream study, which some of you may know. So yeah, you can kind of play around with the filters and see which facilities are kind of low-hanging fruit. So you can set like a cost slider. So I've set it to 90 euros per ton in the middle there, and which was the carbon price at the time I wrote it. Now it's gone up to 100, I think. You obviously see these kind of clusters. Again, Spain's probably coming out a little better than it should do because it's got a lot of pipelines that theoretically could be reused. And then lastly, you on the last slide there, I think I've considered all possible storage geology, and it starts looking like a lot better picture. Bearing in mind, this is our low cost estimate. But what about a dispersed site? So you still get these guys who are over 150 euros per ton, obviously inland sites. I should say I'm looking at one sector. I'm looking at non-metallic minerals because we all know cement and lime need CCS. Yeah, I thought it'd be a good one to highlight. And there are, of course, many dispersed ones. So yeah, check that out. I'll briefly just say this is a sort of forthcoming study we're going to publish. We did with Element Energy, which kind of looks more at where these sites might hook up to in terms of storage and how more storage development can lower the cost. So this is two 2050 scenarios. The one on the left is like a widespread storage case, kind of what the EU, I hope, is trying to put together with their Net Zero Industry Act, where every country can store its own emissions, more or less. And we've looked at the geological studies in this country and the capacities that are available, and the capacities in nearly all cases are adequate to do this. And then we looked at an export case on the right, where everyone's feeding into like the North Sea or Ravenna. You can see the huge volumes which need to be accommodated there in each of those hubs. Just a flag. So that was our kind of literature review based idea of deployment. CCS deployment is about 300 million tons per year in 2050 of industrial emissions, and this just looks at every heavy industry source just to see where everyone would hook up to for completeness, and then you have about 500 million tons. And yeah, I'll stop there. I've got some summary points, but I think the key is these dispersed industries will definitely benefit a great deal from more distributed storage development, and the NZIA may help bring that about, but we'll certainly need a huge cross-border transport network, which is not be limited to the North Sea periphery or coastal clusters. We're expecting more from the Commission to develop a regulatory framework for this cross-border network and technical standards. There's working groups going on this. But ultimately, we need investment in capture plant to drive that, the network and the storage, and the ETS probably not going to be a sufficient driver for many of these dispersed emitters in the timeframe to 2030, because it's probably not going to be over 150 years in that time. So yeah, I'll hand over to Jim. Thanks.
Thanks, Toby. So we've heard a perspective from the UK. We've now got a perspective from Europe, and now we're going to move further worldwide. And so if I could ask Liang, who is the Professor in Sustainable Construction and Infrastructure Transition at University College London, to join us. Prior to joining UCL, G was a senior lecturer in energy finance at the University of Edinburgh. He is the Secretary General and co-founder of the UK-China Guangdong CCUS Centre, an expert panel member in climate finance for the Chinese government, and has been PI of climate finance and CCS related projects with the World Bank and Asian Development Bank. Thank you very much.
Thanks, Julia. And I'm really pleasure to give introduction on CCUS activity in China and a bit of introduction on current works conducted by Guangdong CCUS Center. I want to take this opportunity to appreciate the support by UKCCS Research Center, Scottish CCS, Howden, and many other colleagues in the room for our work in the last 10 years. And this year we will celebrate the 10 years anniversary as the first CCUS center being set up in China. So we set up the CCUS center in China in 2013, and for the first 7 years, it was a difficult time because it's very ambiguous climate policy and the industry's participation was relatively weak. In the first 7 years, we can see about 20 pilot scale to commercial project being deployed in China across the country. But the last 2 years, since China announced a carbon neutrality target by 2060, and it become much more busy and popular in terms of the CCUS technology and being considered as a backbone technology to secure carbon neutrality goal in the country. So right now, is in the last 2 years, more than doubles, over 50 projects in operation and under construction at the larger pilot scale. And only in the last year, I heard from Ministry of Science statistics, more than 100 projects being proposed in just 2022. And the current capture scale is about 7 million tons per year. And the project has already spread over 24 provinces in the country. So one remarkable project is a 1 million ton scale food chain project. And the president of China has visited the project last year. It's in Sinopec, capture from high concentration source transportation by pipeline and put the CO2 in enhanced oil recovery. And Sinopec has also a number of other projects in the pipeline to work on, and CO2 will be used for CO2 EOR and also testing cyanide formation storage. And another remarkable project is also Guangdong CCS Center. I think Stuart has experience and want to promote offshore storage from 2015, and it was very difficult to get CNO engaged. And the last Chinese New Year in 2020, 2021's Chinese New Year, and CNO made up their mind to develop the larger scale offshore storage and use more than 100 engineers to work very hard for 6 months to do the feasibility study. And this project scale is 300,000 tons per year with CO2 being captured similar to cyanide project and injected back to cyanide formation about 800 meters depth. When we have the feasibility study discussion, the panel believe 800 meters is a bit tricky, but they ultimately selected 800 meters, and let's see how things move on. So it comes from a new oil platform, NP151, and the CO2 injection well has been drilling a couple of weeks ago, and the injection will start later this year. And it takes about 45 minutes helicopter trips from South China, Zhuhai, to the platform. And this CNPC PetroChina is also working on a number of CCUS projects across the country, mainly in the northwest and north of China, including developing 3 million ton projects in Xinjiang and 3 million ton CO2 projects in northeast of China. And the CNPC is also very keen to work on some innovative technology and partly inspired by OGCI. So it's always good to engage with international community because they are member of OGCI. So CEO 13 CEO always sit together and discuss of new idea. So they may invest in direct air capture and to be announced later on. And also they will have many new ideas and also set up a climate fund, which will invest in early stage technologies. And this is a picture from the pilot project in the Changqing oil field, which will be likely being scaled up fairly soon. Apart from the oil and gas and power sector, CCUS also take place in the steel industry, and this Bao steel in the Baotou steel in Mongolia has started construction of 2 million ton carbon capture with 500,000 ton projects in the phase 1. And this is also the first project which get the concessional finance policy from People's Bank of China. And 2 years ago, in the before Glasgow's COP meeting, China's central bank announced policy to support low carbon technology and give 1.75% interest rate on average to technology, including renewable carbon capture and storage and other industry emission reduction technologies. So this is the first one, take advantage of the concessional finance. And there are some also unconventional CO2 storage capture technology being demonstrated. And I don't know whether you use VCHAP. There's a company completely irrelevant to carbon emissions from directly the Tencent Group. They invest heavily to introduce car fix technology from Iceland to demonstrate in China and use in potential fields with the bus of storage. And our centers work closely with Tencent and CarFix on a weekly basis, have meeting and try to identify the CarFix storage, the bus of storage site. And we find the best place to demonstrate is in the southwest of Guangdong province, Liang Highland and Leizhou Peninsula. And a team of people now is working locally to try to get the license. And the challenging part is the local government doesn't understand what is CCUS, and they want us to help them to sell pineapple. So we try to convince them CCUS is good for them. There are also few 10 million ton scale CCUS cluster being announced. It's announced, but it's still far away from deployment because they need incentive, regulatory environment in place. One is led by CNOOC, and they signed MOU, very high profile with Guangdong provincial government, with Shell and ExxonMobil. And another one is Sinopec with Shell and the largest steel firm in the world, China Baowu and the BASF. Their both projects are 10 million ton scale, which can be a good sign to move on as a CCUS cluster in the country. And we also, as a center, kick off the first provincial level CCUS planning in the country. And the first study was commissioned by Guangdong Department of Environment to do an official CCUS planning. And then Guangdong DRC this year commissioned another study to do a second CCUS planning that represents how serious Guangdong take CCUS as a role to decarbonize the province. So we look at about 400 million ton of CO2, 199 stationary emission sources across power, cement, steel, petrochemical involved in the Guangdong emission trading system. We try to investigate their retrofit potential, access to CO2 storage site, potential utilization technology, space availability, etc., and develop 4 CCUS cluster: Eastern Guangdong, Pearl River Mouth Basin, West Pearl River Mouth CCUS, and Western Guangdong. So most interesting is the Western Guangdong CCUS cluster near Zhanjiang, which has unconventional storage potential, the Bastos field, and also the water is quite shallow to build offshore CO2 storage demonstration at the Wushi oil field. And we also move out to Guangdong and work on a few projects in like Shanxi, Ningxia, and in Ningxia, they are the per capita CO2 emission is one of the highest in China. I think in Mongolia is the first, Ningxia is the second. So they are very keen to use CCUS to reduce the carbon emission of the province. So we did a study to understand carbon capture potential from all the large stationary emission sources and visit all the major industry partner, and also try to identify what will be the CO2 utilization measure and the potential and promote chemical utilization, geological utilization is close to a Changqing oil field, and also other kind of utilization methods, including biological methods. So this is the planning for the Lingsha porings. And we work with PetroChina to estimate the CO2 reduction potential by CCUS will be increasing. I'm sorry for a mistake of unit. It should be 100 million ton rather than billion ton here. But in any case, the scale is going up, likely going up quite rapidly across different categories of CCUS technology. And the summary can be downloaded on the OGCI's website. And the potential value of promoting CCUS in China is also quite significant, including job and GDP creation. So this report is also now very popular in China. And apart from conventional oil and gas firms, we now have a lot more players in the CCUS field. So like the largest company by market capitalization, Tencent Group, is working with Guangdong CCUS Center closely to and launch a Carbon X Lab on, I think it's on Tuesday. Yeah, I was just in Beijing, and they will locate in the phase 1, allocate 100 200 million yuan to support 5 to 7 technology pilot, and invite scientists to submit their proposal to give them awards, and we give out 20 to 30 awards later this year. So this is also a very good way to encourage emerging technology to be scaled up. And if you are very keen to be involved, we can introduce a Chinese partner to work on this program. And Tencent is also working with 13 industry partner, including China Resource Cement, China Resource Power, Shenzhen Energy, this large industry partner to help build up pilot plant when technology is being selected. So final slide is we are recently commissioned by UK Department of Trade and Investment to identify what will be the UK industry and the research team's role in Chinese CCUS project supply chain. So I think Professor John Gibbon has helped us to organize a questionnaire surveys in April. So I'm here to encourage you to participate, and if you sign up the survey, make sure you got a good meal when you visit me in China. And thank you very much. And it's my colleagues' contacts on Felix Shah's. If you have any things want to follow up on this slide or collaboration, feel free to contact him. Thank you.
So our final 2 presenters are from IEAGHG, and Tim Dixon and Jasmin Kemper. I'll introduce them first because I assume it's going to be seamless transition across. So firstly, Tim Dixon is director of IEAGHG, an international research organization, and is responsible for delivering the technical evidence base to progress carbon capture and storage to members and wider stakeholders, and for international knowledge sharing through the GHGT conferences and numerous workshops. As well as this, Tim is also a director on the board for the International CCS Knowledge Centre in Canada, an honorary senior research fellow at the University of Texas in Austin, and an honorary lecturer at the University of Edinburgh. Jasmin Kemper is the technical program technical advisor at IEAGHG, and has managed a number of technical studies on CO2 hydration, pipeline transportation, accounting for GHG emissions from bio-CCS and EOR, as well as other works. So I'm delighted to pass the mic on to you, you both.
Okay.
Thank you.
Thank you very much, Julia, for that nice introduction. And thank you very much for the invitation to speak here today. It's always a pleasure to work with UKCCSRC. We do the largest CCS related conference, GHGT, and the last one in Lyon. The UK was the 3rd largest provider of abstracts It was a large conference, 1,200 people, and the UK was the third highest out of 39 countries. So that's very much thanks to the UKCCSRC's support and encouragement and UK government support of UKCCSRC. So thank you for that. Challenges of delivering CCS from geographically dispersed industries. Well, we were asked to provide an international perspective in addition to Xi from China. And we thought we'd focus on maritime issues. So myself and my colleague Jasmin Kemper will say a few things about those. First of all, can I ask, is anybody here working on legal topics in your student work, in your dissertations, or as postdocs? Anybody? Yes, one at the back. Okay, great. It's good because, and another. It's good because it's important for CCS deployment, but also you can help me with any questions at the end. So I do have to show this disclaimer that says we're not the International Energy Agency in Paris. They set us up 32 years ago, but so anything we say doesn't count as their views, but we are under their umbrella, and we are an international CCS research organization funded by 37 countries and companies. And what I'm going to talk about is the London Protocol. And the reason I've chosen this topic is that it's a topic of discussion at the moment. If any of you are active in European arena at the moment with EU ZEP, there's quite a lot of discussion about export of CO2. So I thought I'd just do some clarification and point to one challenge that I see. So the London Protocol, international global treaty that protects the world's oceans, primarily against dumping of nasty industrial waste, that is successful. It stopped that. It also inadvertently caught CO2 geological storage. So in 2006, there was an amendment to allow offshore geological storage of CO2. Good, and that's all good. And in addition to allowing CO2 geological storage, the London Protocol produced a set of specific guidelines on what the regulator needs to look for and the operator needs to put into their permit application. And these CO2 specific guidelines are derived from the IPCC's work in site characterization, plume modeling and simulation, monitoring and reporting. And actually these form the sort of basis of what we have in Europe as a CCS directive was derived from these. The one thing they didn't fix in 2006 was an important part of the London Protocol, and that's to stop the export of wastes to other countries who are not in the London Protocol as a way of backdoor route of dumping in the oceans. Of course, CO2 export was caught by this. So in 2009, Norway proposed an amendment that was approved by vote, and that's good news. It requires a certain some requirements. The main one is that there has to be an agreement or arrangement between the countries involved, and that has to be submitted to the International Maritime Organization, IMO, who are the secretariat for the London Protocol. And that those agreements or arrangements, agreement means legally binding, arrangement means non-legally binding, like an MOU. They have to include who's responsible for the different bits of permitting under the CO2 specific guidelines. And importantly, if a country is exporting to a non-London Protocol country, they've got to include within their provisions equal to those provided for by the CO2 specific guidelines by the London Protocol to ensure environmental protection of the same level. So that's good, that's all good. But because it's part of the body text of the London Protocol, it couldn't just come into force after 100 days, like the previous amendment. It has to be ratified by 2/3 of the countries. And that happened very slowly. And after 10 years, there was only 6 countries ratified, and we needed 2/3 of 53. So the legal barrier to export of CO2 remained in place. Drawing upon lawyers in the room here, the Vienna Convention on the Law of Treaties, there was a way of provisionally applying an amendment in advance if the whole governing body agrees it. So Norway and the Netherlands proposed this in 2019 for a provisional application of that 2009 export amendment. So that was good. I mention us there because we're the only CCS organization active in the room in the London Protocol. We have a seat at the table alongside our friends at Greenpeace, for example, and we always present with updates of technical information and project development on relating to offshore CO2 storage. Now, this was successful. This resolution on a provisional application of the 2009 Export Amendment was adopted. Good. So you can now export CO2 for storage geologically offshore. And in those 10 years, we didn't sit idly. We updated the CO2 specific guidelines to take into account the international aspects. And we also developed some specific guidelines, and there's guidelines and guidance on agreements and arrangements as well. So the updates to this, in terms of the provisional application, in fact, this slide is out of date as well. There are 7 countries now have put their declarations to the IMO: Norway, Netherlands, Denmark, Korea, Belgium, UK, and Sweden. Only 1 agreement or arrangements has been made public so far, and that was between Denmark and Belgium last September. And also quite interesting for the lawyers in the world of CCS, the European Commission issued its own analysis just after the Danes and the Belgians issued their MOU, which is an arrangement. The European Commission issued their analysis. And they concluded that because the CCS directive covers most of what's required by the London Protocol, then EU member states and EEA states do not need to have a bilateral agreement or arrangement. So this is open still to some debate, in particular because not all of the EU member states are parties to the London Protocol. So if you're exporting if you're a European member state and you're exporting to Portugal for offshore storage, or Poland for storage in the Baltic, how are you going to get caught up with this? Because you still need to submit something to the IMO. And the European Commission is not a party to the IMO in the same way that the European Commission is a party to OSPAR, the Marine Treaty for the Northeast Atlantic. So there's lots of good lawyer time going to be spent on this, and if anybody's interested in choosing a topic for your dissertation, it could be something along these lines. In the meantime, the Export Amendment got ratified by 4 more countries, but we're still only up to 10. So that's an update on those aspects. We try and help the CO2 specific guidelines and the guidance for arrangements and agreements on export are buried in the meeting reports of the London Protocol. So we pulled them out, and with the IMO, the Secretariat, we've co-authored a report to try and make these more accessible, both to regulators and to operators. And that's available for free to try and help people and make this, give this some clarity. And this was also very important, and you can guess why Norway was the one who proposed the provisional application resolution. They needed this for their Northern Lights project. And within weeks of this agreement in 2019, the Norwegian government was able to give the green light to Northern Lights, and they already had in place MOUs with 7 sources across Europe. Very important there. And since this is moving forward, we've seen the Green Sand project in Denmark has started, in a sense. It started its pilot injection with some CO2 from Belgium. We also see elsewhere in the world, in Southeast Asia, growing interest. So Australia has its deep sea store, proposed offshore storage project, planned to take CO2 from other countries, particularly Japan Steel Corporation. So that's the conceptual project, but it needs this provisional application. And then an interesting one is Australia to Timor-Leste, to the country of Timor-Leste. So the Santos' LNG facility in Darwin, looking to export CO2 to Timor-Leste's depleting gas reservoirs. Interesting because Timor-Leste is not a party to the London Protocol. So the one challenge, I think, as well as just the contractual details that countries and companies will get into, the one main challenge, I think, is if a London Protocol country is exporting to a non-London Protocol country, such as the case with Australia and Timor-Leste, how does the London Protocol country demonstrate or prove that the country who's not a party is going to meet the requirements of the London Protocol? So I think there's going to be good lawyer time invested in that. And it's very important because, as I've mentioned at the very beginning, the London Protocol has worked at the stopping of dumping of nasty industrial wastes. So it's all good. I'll hand over now seamlessly to my colleague Jasmin to carry on a few other points. Thanks.
Thank you, Tim. Yeah, Tim already briefed you a lot about the developments in the London Protocol, and we did a study in 2019 managed by my colleague James Craig, who is now retired. And this was on the challenges of CO2 shipping infrastructure, and it included a techno-economic assessment. And you can hear more about the cost assessment tomorrow in the transportation session, where we'll give a presentation about that. But it also looked and did an assessment of MRV for CO2 shipping and maritime shipping. And it included the London Protocol, and you've already heard a lot about that from Tim, but it also included an assessment of the EU ETS. And on the positive note, in December 2022, it was agreed to include maritime shipping emissions within the scope of the EU ETS. And there will be a gradual introduction of obligations for shipping companies to surrender allowances. It will start with 40% for verified emissions from 2024, going to 70% in 2025 and to 100% in 2026. And vessels of more than 5,000 gross tonnage will be included in the monitoring, reporting and verification regulation from 2025 onwards, and in the EU ETS itself from 2027. Smaller vessels between 400 and 5,000 will be included in the MRV regulation from 2025, and in the inclusion in the EU ETS will be reviewed in 2026. The new agreements also take into account geographical specificities and also propose transitional measures for small islands, ice-class ships, and journeys relating to very faraway regions and public service obligations. And certain member states with a relatively high number of shipping companies, no surprise, will receive auctioned allowances of up to 3.5% of the ceiling and will be distributed among all eligible companies. And then it was also agreed to include non-CO2 emissions like methane and N2O in the monitoring, reporting and verification regulation from 2024 and in the EU ETS itself from 2026. And I've also included the link for you if you want to know more about the announcement that came out in December. It included a lot of what the European Commission wants to include and cover in the future. One thing that we have not talked about in detail in our panel session so far is CO2 stream impurities. And it's a very important issue because the stream impurities can vary greatly depending on the stream, on the source of the CO2. And we have actually done a study together with Newcastle University. It was quite some time ago. And now the issue is kind of popping up and nipping in our backs again. So it is an important issue in the context of hubs, because then you might have a mixing of different CO2 streams, which can lead to a variety of impurities ending up in the stream. And the criteria can also depend on what can be in the stream, depending on what the transport option of your hub and cluster is, whether it's pipelines or ships. And it can also have an effect on the costs, depending on how you have to build your pipeline or your ship. And the first EU hub project might be set, and that's the Northern Lights project, might actually be setting the de facto standard on CO2 impurities or stream composition. And the question then is that a good thing or is that a bad thing? Some people think it might be a good thing because finally a de facto standard is set, but other people might think, yeah, but what if this de facto standard is very specific to that project, but our project is different. And then if the other project sets a de facto standard, yeah, that might cause issues. And there's currently a work underway in the EU Zero Emissions Platform. There's a new working group on shipping, and also in the ISO TC 265, there is a new working group on shipping issues. Yeah, and this is it from our side. The last slide, this is our member slide. You can see our different member countries and also our different industrial sponsors. And here you can see they are from a very geographically diverse background. Several different industrial sectors are present. And yeah, so for our members, the issues that we are discussing today in this session are of very high importance, and they definitely will also shape our research program. Thank you.
So if I could invite the panel to take your stool at the front, that would be lovely. So we've heard a lot of different challenges there, ranging from still some technical issues around impurities and how you transport those in different modes of transport and how that all mixes together at the end. We've heard policy challenges, we've heard legal challenges, we've heard challenges still around standards and standardizations, particularly across different countries. So now the floor is open to you. If there are any questions that have arisen out of the presentations that you've heard today that you would like to ask the panel's opinion on. Go on.
Yeah, I just saw in the news this morning that a rail transport study had been announced for an Infinium plant on Humberside. So it's just started. Don't think we heard much about rail transport. So I'm interested to know about rail transport in various people's plans, and also since she's here, any rail transport of CO2 in China.
Okay, Tim, would you like to? Oh,
Sorry,
okay. Put your hand.
Hello. Yeah. So no, yeah, I can't really add that much more. I mean, I than what I said, which is the Kajawi cement plant in Poland. I mentioned rail as probable means of transporting to the port in Gdansk, and it's seems to be on the table for one of the French projects, the K6 cement plant. But I do get the feeling that most projects are wanting to use pipeline if it's all possible. It was also, there's a study for the North Rhine-Westphalia region, which considered rail to the port of Wilhelmshaven. But yeah, it seemed to require an awful lot of trains, would be my main takeaway. And I think, again, with the planning of this new pipeline grid for Germany, and also the Delta Rhine corridor, which goes to Rotterdam, would seem to be a more favourable option. I guess it's a way of getting started, at least. Like shipping, it's a bit of a flexible option which you can maybe get going more quickly. So yeah, I know you.
I don't know, Aaron, have you? Oh.
Can I ask a question back? If they're in the region of the Northeast Cluster, do you know why they're looking at rail transport? Can you guess? I didn't see the news myself.
Well, I mean, I think it's it must be a capex versus opex and a flexibility issue and timing. I mean, clearly, somebody mentioned 30 truck movements out of Hope Valley Cement. I know Hope Valley Cement very, very well. That's one train, isn't it? One train a day. That's not too bad. 100 was it? Well, whatever it was, it's still only one train.
Yeah. So I was looking at, I think this cluster that's emerging in Avonmouth, they're looking at using train in order to get to the ship. And I'm scribbling down some numbers here. So I think they were looking at, so sort of 2,000 tons a train, which that's like 0.7 megatons a year. So that's, yeah, I think trains can actually move a fair amount of CO2, a lot less, a lot more than roads. I think a train, if a train is 2,000 and a truck is like 20 tons, I think that's 2 orders of magnitude different. I think, I mean, I'm interested to know. I'm definitely not the expert on, but yeah, those are the numbers I've seen floating around.
Okay. We move on to another question in the middle there.
Thank you. Hi, Ryan Habala from Aker Carbon Capture. I'll ask again a question that was asked earlier, but it was framed in the UK storyline. So I guess I think I would like to take it out of that storyline and ask it to this panel. What about the elephant in the room with regard to costs, but also regulation? And that is onshore CO2 capture. It seems like we're not talking enough about it, and I would like to understand why.
So I assume that's onshore CO2 storage.
Yes, sorry.
Yeah,
yes,
sorry.
yes.
Okay, who would like to start off with onshore CO2 storage?
I'm not, yeah, again, I'll hand over to Tim, but my sense is that in the UK, there's been an evolution over time. We sort of 15, 20 years ago, we discussed onshore versus offshore, and yeah, we should probably do offshore because, well, that's where things are, and public might not be particularly keen on onshore, and that's how it's evolved. And is there a strong reason to change that direction of travel? I'm not convinced there is. The geology onshore is not as strong. There doesn't appear to be as much capacity from what I recall. So I'm not sure what the rationale would be. I mean, I guess if there was great storage onshore and you're not storing under the sea, then it could potentially be cheaper, but I don't think that there's much geological evidence to suggest that that's the case.
I can add, well, to reinforce what Aaron just said, I think the UK, when it first started looking at CCS, it was let's go offshore first, was the sort of implicit non-public policy view. One, because there's good storage potential offshore, and two, it avoided some potential public issues onshore. But if your question's non-UK, if it's international, we have a lot of onshore storage in the US and Canada, and some in Australia as well. So it does happen. It is being developed here in the world as well. I think it's more, there's a Northern European potential storage offshore, and it addresses some of the sort of societal concerns potentially. But we've seen also that the public get interested in offshore storage as well. So.
She's got something to I mean, yeah, I think Denmark's a really interesting case on this because, like the UK, they initially thought it's going to be all about offshore. It's a lot easier, but in the last year or so, they have assessed onshore options and found there's lots of places where, yeah, they initially spoke to communities, and some communities said no, some said yeah, fine, and that's led to two projects. I think maybe, well, there's one kind of pilot storage which is already happening, actually small scale. There's two larger things proposed onshore, and I think they're getting much more interested in it as a lower cost option. And elsewhere in Europe, of course, it has to be an option in some countries away from the North Sea, and there's a few proposed, one in Croatia, one in Southwest France, early days. But yeah, definitely keep an eye on the Danish projects.
Is there any perspective from China, Xi, around onshore storage?
Yes, definitely onshore storage is much lower cost options. But from Shanghai to Guangdong and Guangxi, the southeast coastal area, there's very limited onshore CO2 storage site, apart from conventional onshore storage like basalt, but it still is a space, and it's very limited. So offshore is an important option to keep it open, but our analysis shows it have to be at certain scale to like 10 million ton or 40 million ton even for one platform to make it financially attractive and viable. And that will much reduce the levelized cost for transportation and the storage. So the question is how to move to that stage. And onshore storage will potentially have some public perception issue, but in some remote areas, are very attractive options.
Thank you. Any other questions? Yes, who's in the middle?
Hi, Bruce Adderley from UKRI. I run the Transforming Foundation Industries Challenge. I was very interested to hear Aaron issue the words cement, ceramics, glass. That's very much in my neck of the woods. And my team, they know that I've got an industrial CCS background, so I chunder on about it. But a number of them don't believe me that it can be a realistic prospect for dispersed sites, and they're technically, and they're still going, no, boss, you've not got the right end of the stick there. So what arguments do the panel think I have to convince those technical people in my team that this is an option?
So, Aaron, would you like to start with that one?
I think sort of going back to when was at the CCC, we were advising on the net zero target, and then we're actually looking at industry decarbonisation ambition. It was really very low before that, and I think the clear story was for industry decarbonisation. Well, we should probably be putting in a similar level of effort to that across the economy, and as good sort of techno-economic analysts, there is an element of pricing that up, and that does capture the effort. And actually, if you're looking at the kind of costs of decarbonisation in industry, and even in those difficult-ish dispersed sites, they're really sort of, they're highish, but they're middling when you're talking about the costs for net zero. So look at some of the more expensive measures in buildings or in some of the hardest areas. And actually you look at those measures and they really are in the middle. So that's always been my pitch, was that industry decarbonisation needed to be increased to bring it in line with the level of effort in other sectors. And I think that message has generally chimed, because I think industry don't want to feel that, oh, my sector's the one that isn't going to sort of put its fair share in. And so I've always found that chimes with most.
One simple point to add: if your industries were not in the UK but in Europe, they'd be paying about €100 a ton for their emissions at the moment. I don't know how the UK ETS is linked to the European prices. If anybody else knows the price in the UK, but anyway, that's a cost that equivalent companies are paying in Europe, certainly.
Any other panel perspectives on?
Yeah,
Yes,
maybe I
Jasmin.
can comment, because we run a research network on solid looping technologies, which includes calcium looping on cement plants in particular. And what's really important, and it's part of our job, the dissemination activity of the work that we are doing. And so it's always good to have as many people as you can from those industries involved attend those research meetings, meet the academics. And we did that actually 2 weeks ago in Italy, where we showcased the results of the Kemper project, who investigated CO2 capture technology in a cement plant. And they actually have a pilot plant there integrated into Buzzi Unicem's plant in Banasca. And it was really interesting for other cement companies to come there and have a look that it actually works and can work, even if in that plant it was really difficult to fit the capture plant into the layout. But the engineering company they worked with in the project did an excellent job in doing that. So that should probably address some issues that people have, that it can be done.
Great, thank you. Any other? Yes, please.
Can you hear me? Yeah.
Can you hear me now? Yeah.
Yes. Yeah.
Wasim at Brook University of Southampton. I feel like I'm stabbing you in the back, Tim, because I was supposed to help you with answering questions, but I'm going to ask you questions now. I think this is for Tim and Jasmin. A couple of quick questions. I think the first one is on Jasmin. You mentioned the Fit 55 European, the European deal, and the inclusion of shipping in the emission trading scheme. Is it working? And there are plans for domestic shipping to be included in the UK emission trading scheme as well. So I was wondering, how do you think that these would work together? I think that's the first question there. And the second question is around whether you think that the shipping industry has developed. It's not entirely new for the shipping industry to transport CO2, but to do it at this scale is a challenge. And I'm wondering if you think that we have the appropriate contractual templates in place for that, because I've looked at other commodities like LNG, for example, and there are specific clauses that are included in it based on experience and so on. And do you think that we're at a point with the transport of CO2 by ships are we there in terms of the contractual arrangements that are needed for it to be developed at that scale?
Tim will take the second question. I will take the first question. With regards to when you have different schemes, that was actually one of the outcomes of the assessment in our CO2 shipping study. So the contractor assessed all the MRV rules, and they found out that because you have the London Protocol and you have the EU ETS, you have to report under two different schemes, and that puts like additional work on the shipping operators. So, and another issue that came up was that, for example, the case was set in Norway, and the thing is, as a Norwegian country, if they are implementing any EU law, then any issues that are in the EU ETS directive or MRV regulation will be taken on into national law and will pop up there as well. So that's another issue that has to be thought of.
And just on the second point, I think it's a really good question. And one, I don't know the answer. I think you can imagine that the shipping operators would look at the regulations they have in contractual details they have in place for other gases at the moment, like LNG, plus add an emissions trading perspective if it's within Europe. But I think I would recommend if you could join in the EU ZEP working group. You sound like the right sort of person they should have with the right expertise as they work these things out at a European level. Well, thank you.
Thank you. Down here at the front first. I'll just keep you running up and down this side.
Thanks, Tim. This is a question for you. You mentioned Darwin feeding back into Timor-Leste, and I just want to see how does it look if we go away from the European Union and you're looking at it from a Southeast Asian perspective. What are the kind of protocols in place? Do any apply? Are there any pricing mechanisms there?
So certainly the London Protocol is global, but there's not so many of the Southeast Asian countries on parties to it. So there's a gap there. UNCLOS is the overarching law of the seas, United Nations Convention on the Law of the Seas, and that within that asks countries to follow best practice in whatever they're doing. So there's a sort of umbrella thing in place. I assume most of the Southeast Asian countries are party to UNCLOS, but it's a fairly light touch requirement in that sense. So what may be more useful, and I think it's Papua New Guinea are in the London Convention, but not in the London Protocol yet. What is potentially useful is the ISO standards that are available under TC 265. Now, if a country has got an oil and gas industry, you can assume it's got some regulation of that, including environmental protection, and countries can potentially use the ISO standard for storage in conjunction with the oil and gas regulations to try and to make a way going forward with some level of environmental protection in place. But it's an area ripe for capacity building, certainly. Sorry?
There's nothing in place at the
There's
moment.
nothing in place at the moment, but there's some World Bank money gone to Timor-Leste at the moment to help them. And part of that work is developing their regulations for CO2 storage.
I think we've got probably time for one more discussion point. And there are a few coming in online as well. So I'll probably take two more. So I think there was one in the middle up there.
Hey, thanks. Yeah, so Richard Little, I'm RWE. I'm the director of the Pembroke Net Zero Centre, centred around the Pembroke Power Station down at Milford Haven. It's more of an observation than a question, but it is a bit of a challenge. And I think it is important, the distributed industrial base that we have. I was formerly the manager of the Aberthaw Power Station, which isn't far from here. If you're flying out from Cardiff Airport tomorrow, you'll get a good view of it and the ash disposal quarry that's there. And I'm reacting to the sort of the 100 lorries a day versus trains types discussions that we had earlier. Now Aberthaw at its peak, which it's been closed for a few years now, coal power station disposed of ash on a continuous basis, originally on site, but then when we ran out of space, we had to dispose off-site to a quarry. That was 120-ton lorries a day. That's how we started by lorry, and we had a scheme to build a conveyor equivalent to a pipeline. John was talking about analogies. So that scheme for the conveyor was £15 million. We never ever justified it because the lorries just worked. It was OPEX versus CAPEX, but 100 lorries a day is very resilient. A lorry breaks down, you've still got all the other lorries. It's very, very flexible. That feels similar to shipping. Train, absolutely viable. We had coal trains, 1 or 2 a day, maybe, often 1 a day. And then you had a continual stream of lorries, one every 8 minutes, 10 minutes, whatever it was during the day. Nobody noticed. The lorry goes past, it's 10 minutes till the next one. It's completely doable, and we've done it before. So when you're looking at moving an industry, as was suggested in the discussion earlier, to be nearer a pipe, you're always going to be facing that kind of choice. It's for moderate-sized industries, these things are eminently doable, and we've done it before.
Thank you for your comment and observation. Does the panel want to add anything to that observation?
I think it's a really great example. I'm merely intrigued to know. I just almost kind of want to look at the roads around in the Peak District, because I'm making some probably very poor assumptions, perhaps, but I'm making some assumptions that they may be more challenging roads than around Aberthaw. But maybe John has, because John obviously knows Hope well.
Just say is this working? Yeah. If you come out the Hope Cement Works and you want to go to the Highnet cluster, which is touting for the business, you have to go over Winnett's Pass, which is distinctly challenging for a truck. Whereas if you go to Humber and through Sheffield Way, it's on the flat. So there may be some considerations there. So I think you're partly right, Aaron. But since they closed the old road over Mamtor due to subsidence, which is an interesting bit of geology, then it's got a bit more challenging.
So just say, obviously, you think about the emissions of these transport solutions as well, and that may not be so easy to deal with the trucks. They're using a truck at the waste to energy facility in Oslo, as many of you will know. I think the idea is to have electric trucks or hybrid or something. But anyway,
yeah, it'd be interesting what happens with cement, because the other complicating factor, which I'm throwing in a bit of a red herring, but it's not, is how much CO2 gets taken up by the cement over its lifetime, which can have quite a big influence on the numbers too.
Okay, I've got one last question, which has come online, which I would like to ask to each of the panel members in turn to get your thoughts and to conclude this panel. So the questions come in as, how can countries with more advanced CCS regulatory frameworks assist developing nations in establishing and implementing effective regulations for CCS deployment? So what learning can we take from countries who are deploying CCUS?
Okay. Well, it's an area of personal interest of mine, actually. So who asked the question? So it's okay. Keep them anonymous.
Yes,
just in case.
say.
But it's really important, and I think that's why the World Bank and the Asian Development Bank had the trust funds, the CCS trust funds, for that very purpose of capacity building in all senses: storage assessment, source assessment, and regulatory development. And it's a real shame that those trust funds are coming to an end, because the donor countries' money has come to an end. They need to be closed, and we very much hope that the donor countries, UK government and Norway and Australia, can fund new trust funds to continue that work in developing countries. And then the other part of that is not just money, but it's the sharing the knowledge and expertise. And so encouraging the development of centres of excellence in countries is really important, to act as a node into those countries for such knowledge. And the Guangdong CCUS Centre is an excellent example of that. And they can take from the centres of excellence in developed countries with CCS, such as UKCCSRC, the International CCS Knowledge Centre in Canada, Gulf Coast Carbon Centre in Texas. Knowledge centres are the second part of my answer to that.
Okay. Anybody else? Yeah.
I'll just add, because we are from the same organization, and what we also do, or what Tim does, is he's always present at the COPs, and he's always organizing some side event. Sometimes a CCS in a very specific location, like in the Caribbean or in Nigeria. And this is a really good opportunity to kind of get connected to people from those countries, and also to share knowledge, and also make them aware what organizations are there to help them with potentially funding or technical expertise if they want to set up CCUS infrastructure.
And just to the list of centres, thank you very much, Jasmin. Just to the list of national centres of excellence, I should also mention the National Carbon Capture Centre in the US as well, because Frank's in the room. And I would mention it anyway, even if Frank was not in the room.
Thank you.
Yes.
Does any other panel member want to comment on maybe on the Guangdong Centre and the work that they're doing?
Yeah, I think it's a very good question. So most developing countries missing the CCS regulatory framework, and without the regulatory framework, it's difficult to properly incentivize CCS or properly include the CCUS in the carbon market, or including in even voluntary carbon market. But the reality sometimes is the developing country have so many agenda in terms of legislation and regulation. And if they are not prioritizing CCUS or see the importance, it's very hard to allocate resource to do the administration resource for regulation and for CCUS, and understand the technical insight. So I think it's a very big gap we need to address, and carry on working hard to make sure a regulatory framework is set up country by country in developing world.
Thank you. Okay, with that, may I thank all of the panel members for their very informative and well-researched presentations, which have given us an excellent perspective on what's going on with regard to distributed CCS sources throughout the world. So thank you very much.